Today's topic is mental illness, specifically the type that makes you believe that the Earth is flat, the moon landing was fake, and space is fake itself. I'm going to be going through all of these in a series of 3 videos, starting with why the Earth isn't actually flat, and I will be providing actual evidence and examples to how all of it works. I know there's people out there who, no matter how much you explain anything to them, they have a closed mind and will not believe anything but their own. So feel free to argue with me in the comments. I am willing to make a completely separate video about that. Okay, so apparently the curve of the Earth is fake. But here's my first question. Why? Why is the exact same general curvature visible in photographs from completely different cameras, different missions, different altitudes, and different parts of the world? If somebody wants to claim that every single one of these is CGI, a projection, a fisheye lens, or some kind of NASA trick, then they have to explain why completely independent observations keep producing the same result. And then there's an even simpler explanation. Why is basically every large planetary body we observe round? Seriously, look at the planets. Mars is round, Venus is round, Jupiter is round, Saturn, Uranus, Neptune, even the moon is round. So we're supposed to believe that gravity was perfectly capable of making all of these enormous objects roughly spherical, but Earth somehow decided to be a fucking pancake. That's not how gravity works. When an object becomes massive enough, its own gravity pulls its material toward its center from every direction. Over enormous amounts of time, that causes large bodies to settle into a shape that's approximately spherical. That's why planets are round. Think about something like a balloon. When you inflate it, the material spreads outward in all directions because the pressure inside is pushing outward. Gravity isn't exactly the same mechanism, obviously, but the useful idea here is that when forces act towards a common center, you don't end up with a random flat shape. Now, here's where people get confused. Earth is fucking enormous. It's about 12,742 kilometers across, and a human is roughly 1.7 meters tall. That's a difference of roughly 7.5 million to 1. If I scaled Earth down to a sphere about 13 meters across, a human would be roughly 1.7 millimeters tall. Basically a tiny grain of salt standing on something about the height of a 4-story building. So when someone stands on Earth, looks around and says, "Where's the curve? It looks flat," they're essentially asking why a grain of sand can't look at the surface of a giant sphere and immediately notice that it's curved. So here's one of the arguments I see a lot on posts that NASA makes on all around the internet, especially Instagram. If there are thousands of satellites orbiting Earth, then why don't we see satellites in basically every picture of Earth? Because satellites are absolutely tiny compared to Earth. When you're photographing an entire planet, you're trying to fit something that's over 12,000 kilometers wide into one frame. A satellite might be only a few meters across. At that scale, a satellite isn't going to look like some giant spaceship floating next to Earth. It's going to be either completely invisible or just a tiny dot. And there's another problem. Satellites aren't necessarily going to be anywhere near the camera's field of view. They're orbiting at different altitudes, inclinations, and positions. So asking why isn't there a satellite in this particular photograph is basically like taking a photograph of a football stadium and asking why you can't see every single ant crawling around inside it. Okay, then there's another one. If space is real, why don't we see millions of stars in every photograph? This one is actually really easy to demonstrate. Imagine there's something barely visible behind me. Now point an extremely bright flashlight directly at the camera. Can you still see the faint object? Of course not. It didn't disappear. Your eyes, or the camera, just can't simultaneously expose for something extremely bright and something extremely faint. The same thing happens when you're photographing something brightly illuminated by the sun. The lunar surface, astronaut spacecraft, or Earth can be extremely bright. So the camera exposure is set to capture those bright objects. The stars are dramatically fainter, so they don't show up. Here's an experiment you can do yourself. Take a picture of a bright light at night while there's something very faint in the background. Expose for the bright light. The faint objects disappear. Expose for the faint object, now the bright light is completely blown out. Stars didn't disappear, the exposure changed. Now let's talk about sunsets. A common explanation for flat Earth is that the sun doesn't actually go below the horizon. It just moves farther away from you. Okay, let's assume that's true. If the sun were simply moving farther and farther away across a flat surface, we'd expect it to gradually become smaller and dimmer. But that's not what we observe. The sun maintains roughly the same apparent size throughout the day, and then the lower edge disappears below the horizon. That's exactly what you'd expect when a spherical Earth rotates and the horizon physically comes between you and the sun. Okay, here's something you experience literally every single day. Time zones. If Earth were a flat surface with the sun simply moving around above it, you need to explain why different parts of the world experience completely different times of day at the same moment. At the exact same moment, it's daytime in one part of the world, sunset somewhere else, and the middle of the night somewhere else. On a rotating globe, this is incredibly simple. Half of Earth is facing the sun and experiencing daytime, while the other half is facing away from it and experiencing nighttime. As Earth rotates, different locations move into sunlight and then back into darkness. That's why we have time zones. Exactly why, on places like Antarctica, you can see daylight. You can't even see night. It's constant daytime. Now, here's one I hear a lot. If Earth is round, airplanes should have to constantly point their noses downward to follow the curvature. It sounds reasonable until you remember what an airplane is actually doing. An airplane isn't trying to fly in a perfectly straight line through empty space while Earth curves away underneath it. It's flying through the atmosphere while gravity pulls it towards Earth, and its flight path is continuously adjusted by the aircraft's controls. And here's the important part. Earth's curvature is extremely gradual. The surface doesn't suddenly drop away underneath the airplane like this. It's an enormous planet. The curvature over the length of an airplane is tiny. If the Earth is round, why does it still look completely flat when you're sitting in an airplane? Because you're still fucking tiny compared with Earth. A commercial airplane usually flies around 10 or 11 kilometers above the surface. That sounds incredibly high when you're standing on the ground. But Earth's radius is about 6,371 kilometers. You're basically putting a tiny camera a few kilometers above a planet that's thousands of kilometers in radius. The curvature is real, but it's subtle. When you're looking at a tiny section of an enormous circle, the curve can look almost perfectly straight. There's another problem with using photographs as proof. Camera lenses aren't perfect representations of geometry. Wide-angle lenses can exaggerate curvature, or other lenses can make it much harder to see. So one photograph isn't a particularly good way to determine Earth's shape. Instead of asking whether you personally think you can see a curve in one photograph, we can actually measure Earth's curvature. Here's probably one of the most common flat Earth arguments. Water always finds its level, therefore the Earth has to be flat. And this sounds pretty convincing until you ask what level actually means. When you put water in a container, gravity pulls the water toward the center of mass. That's why the surface settles into a level surface. But level does not mean flat across the entire universe. It means that the surface is perpendicular to the direction gravity is pulling locally. On Earth, gravity points approximately toward the center of the planet. So someone standing here has down pointing this way, while someone on the opposite side of Earth has down pointing in the opposite direction. And both people can still have water that is perfectly level relative to where they are. In fact, the oceans themselves follow a curved gravitational surface around Earth. Here's something you can actually observe without going into space. Watch a ship travel away from you across the ocean. You don't see the entire ship gradually shrink until it becomes an invisible dot. The bottom disappears first. Then more and more of the ship disappears below the horizon until eventually you can't see it anymore. And here's the interesting part. If the ship is below the horizon, zooming in doesn't magically reveal the missing bottom. If this were purely a problem of the ship becoming too small to resolve, Increasing magnification should bring the entire ship back, but it doesn't bring back the part that's hidden below the horizon. That's because the Earth's surface is physically coming between you and the lower part of the ship. Atmospheric refraction can sometimes let you see objects farther than simple geometry predicts, which is why individual observations can vary, but that doesn't remove the underlying curvature. Why does Earth's shadow on the moon always look round? Here's another observation humans have been making for thousands of years: lunar eclipses. During a lunar eclipse, Earth moves between the sun and the moon, and Earth's shadow falls across the moon. And look at the shape of that shadow. It's curved. Not sometimes, not only from one particular angle. Earth's shadow consistently appears circular during lunar eclipses. A sphere naturally produces a circular shadow regardless of which direction you're looking at it from. A flat disk can also produce a circular shadow, but only from certain orientations. So if you're trying to explain all lunar eclipses with a flat disk, you have to explain why the geometry keeps producing the observed circular shadow. That's a much more interesting argument than simply saying Earth is round because we have pictures. So, is the Earth flat? We started with the claim that the curve in photographs is fake. Then we looked at the size of Earth compared with human, why airplanes don't need to constantly point downward, why water can be level on a curved planet, why ships disappear below the horizon, why Earth's shadow during lunar eclipses is circular. And none of these things require you to blindly trust NASA. You can observe some of them yourself. You can measure some of them yourself. And the observations consistently fit the same model. We're living on a roughly spherical planet. And that's only the beginning, because next time we're leaving Earth, we're going to talk about the claim that space itself is fake. The sun, satellites, rockets, the ISS, spacewalks, and why the sky isn't some giant fucking projection screen. Leave your arguments in the comments. I am more than happy to look into them. Until part 2. See you.